Here we have the integral of sine to the 6th x dx. A couple of things we could do. We could use half-angle formula. It's going to involve some work, but doable. We could also use the reduction formula we came up with a bit ago. Now, let's do it both ways so that we can kind of compare these. So first of all, we're going to think of this as sine squared x to the third, and we'll use the half-angle formula. So this is going to be 1/2 times 1 minus cosine 2x, and that would be to the third dx. Now in looking at this, we have a 1/2 to the third, so we could bring a 1/8 out in front. And this needs to be multiplied together 3 times. So we have 1 minus cosine 2x, and if we multiplied 2 of those others together, we'd get 1 minus 2 cosine 2x plus cosine squared 2x. Now we need to make sure we multiply both terms here to the 3 terms here. Now, if we did the ones, we would get 1 here. On the cosine 2x terms, there's minus 1 of them there, and there's minus 2 of them there, so minus 3 cosine 2x. On cosine squared terms, we got 1 there and 2 more there, so that's plus 3 cosine squared 2x, and then last times last would be minus cosine cubed 2x dx. Now in looking at that to see what we could do with that, we could integrate this term, we could integrate this term. This one is actually going to need a half-angle formula again. So this would be 3 multiplied by 1/2 times 1 plus cosine. It already was a 2x, so that's going to become a 4x. And then we could integrate that. Now this one is a cosine raised to an odd power, so we can split one of those cosines off, and we could use a Pythagorean identity and do the integration that way. So let's write down what we've got. We've got 1/8. We can go ahead and integrate there and get x. Integrate here and get minus 3/2 sine 2x. Looking here, we would have a 3/2, so that's going to be plus 3/2 x, and here we'd have a 3/2 cosine 4x, so integrating that, that would be 3/8 sine 4x. And then we have minus the integral of, this was a cosine squared 2x and a cosine 2x dx when we split it up, so we can replace this with 1 minus sine squared 2x and then cosine 2x dx. Now let's see what we can do here. So we can combine these two, and that would give us 5/2 x, and we'll go ahead and distribute the 8 through. So that's going to be 5/16 x, and then this would be minus 3/16 sine 2x, and then we'd have plus 3/64 sine 4x. And now to work this last integral, we could do a u substitution. So let's go ahead and figure out what that would need to be. I'm going to go down here below to do that, and then we'll put our final answer on the end here, that where what we've got so far. So looking at this, we could let our u be sine 2x, and that means our du is going to be 2 cosine 2x dx, and I see I have the cosine 2x dx part, so I'm going to make this a 1/2, and know I can replace that with 1/2 du. So doing the u substitution, this would be minus the integral, we're just working this piece right here, 1 minus u squared, and then du with a 1/2 there. So that's going to be minus 1/2, and this would be u minus 1/3 u to the third, and then our constant of integration. So we'll go back up above now and finish our answer resubstituting u as sine 2x. Now remember, we also had this 1/8 that we were distributing out in front. So this is going to be minus 1/16 sine 2x. And then that will be 1/6 and that, so plus 1/48 sine cubed 2x plus a constant. And then it looks like we have just a couple like terms. We'll move this out of the way so we've got room for our final answer then. And our final answer will be what we have here above, but we can combine these like terms. So it looks like we have 5/16 x, and this would be minus 4/16, so minus 1/4 sine 2x plus 3/64 sine 4x plus 1/48 sine cubed 2x plus a constant. Now that was a lot of work, so let's go ahead and in this following video we're going to use the reduction formula and see if it's any less work